Okay, let's recap the lesson. So I'm kind of hiding this because I don't want you to see the graph because that's what we're going to try and do. But today what we're going to talk about is graphing polynomials by using their roots. Okay, so we just want to get a general shape of a polynomial. Okay, so before we start on this one, roots, x-intercepts, zeros are all the same thing for us right now. Okay, so we're going to try and graph a polynomial using roots. Well, let's look at an example. Okay, so here we go. I've got p of x. P of x, because it's a polynomial, is equal to x plus 3 times x minus 1 times x plus minus 4. So it's already factored. We already have our mini equations, so we can set them all equal to 0. And we can solve. So we know that if we solve this mini equation, we get x equals negative 3. If I solve this mini equation, add 1, I get positive 1. If I solve this mini equation, I get 4. Okay, so then what I want to do is graph those x-intercepts. So they go there, there, and there. Okay, so I just put these, negative 3 there, 1 there, and 4. Now, how does this happen? Well, I do know if I multiply and multiply it all the way out, and if I did all this, I'd have an x times an x times x. So I do know that I have some x cubed equation, positive x cubed. So I know that end behavior, it's got to go off like that, because we talked about end behavior yesterday. Now, from there, I can just sketch it in. But n's going to the x approaches infinity. We know that in this case, y approaches infinity because it's a positive x cubed. Then it just has to go through the root, through the root, through the root. And that's an easy sketch. Okay. On the next example, let me hide it. I don't want you to see the answer yet. Again, I know this is a x cubed because I've got a x times x times x, but it's a negative x cubed because I can get a negative x times an x times an x is a negative x cubed. Okay, so then I solve for the roots, and I get my roots to be at, solve it, I get 3, I get negative 2, and I get negative 1. Okay, so I put those down, except for this time, because of end behavior, as x approaches infinity, we know it's a negative x cubed, then y will approach negative infinity, so we know the end behavior looks like this. So it's got to go through the root, it's got to come back down to come back through the next root, back up to go through the next root. Okay. All right. Moving on to another example. So then I talked about these things called double roots. So we looked at this equation, and we know we have, it's an x cubed again, but it's a positive x cubed. I know that. If I went x times x times x, positive x cubed. So I do know end behavior. Before I do that, I know my zeros are at 0, negative 3, and negative 3, because I could have written it like this. So I actually have the graph going through negative 3 twice. How does that work? Well, it goes through negative 3, and then comes back through it. Okay, so it has to go through negative 3 twice. So it goes through it, comes back through it, it goes through at 0, and we know because it's a positive x cubed end behavior, as x approaches infinity, we know that y has to approach infinity because it's a positive x cubed. Okay, and then of course that shows why, if we have a triple 0, x cubed, the same thing as x minus 0, x minus 0, x minus 0. So it's got to go through 0 3 times. So it goes through it, back through it again, and back up. Okay. So what I had for you guys was a worksheet, and on the worksheet I wanted you to do a couple of things. I wanted you to sketch the graphs. Here's an example of it. Find the zeros, sketch the graph. I also want you to talk about end behavior, so sketch the graph and talk about end behavior. So this is what I had for you today. All right, and there we have it.